Hello, this is David Cavuto, Product Manager with Cribl Search. This is part 3 in a 4-part video blog series. In this video, we'll be demonstrating how to send data from Cribl Search into Cribl Stream using the send operator at the end of a search string. We'll also set up a route in Cribl Stream so that data will loop back into the data lake Amazon S3 destination that we previously created in Stream. Finally, we'll demonstrate exploring that data lake result set in Search. If you haven't completed part 1 and part 2 yet, please feel free to pause here and go back and start with part 1, setting up the data lake destination. If you've already completed the configuration in the first 2 videos, this is the right video for you to watch. To begin, we'll open a Stream window and we'll open a Search window. Here in Stream, we'll click on our default worker group, we'll go to Data Destinations, and you'll see that we have this S3 destination already configured. That's the eventual goal of pushing data back into our data lake destination. For now, however, we'll go to Data, then Sources, and we'll click on Cribl HTTP. We'll see that this source is created by default and it is active. It has address 0.0.0.0, which means it will respond to any local address. We'll see it's already configured to listen on port 10200. That's the default port. It's useful to know because that's where Search will send the data by default when you use your send operator. But you don't need to make any changes in this. Now let's go back into Search and we'll demonstrate how data might appear in Stream when searched. We click on the left on Datasets, we click on Cribl Internal Logs just to get some data in the window, and we'll see that that generates 1,000 results. Let's take a look at how that looks in Stream. If we click on Stream, then we click on the source, and then we click on Live Data, we can hit Stop, then Capture again, change it to 300 seconds to make sure we have a long enough window to see the events that we created. I'll hit Start in this window, and then go back into Search window, and we're going to add a pipe and the send operator, and that's all. If we hover over it, we can see that there are many different options for the send operator, but for now, we're just going to use the default send and hit Enter and observe the results. Now notice the difference. Instead of seeing results in the search window, they're sent to Stream. In the search window, we can see that no results are returned. Instead, we should see the progress of the send operator. If we close this and look at the monitoring tab in Stream and look at the source in Cribl HTTP, we can see that there are exactly 1,000 events sent to the Cribl HTTP source. But where did that data go? Well, if we look here in Manage Default Routing Data Routes, we'll see that by default, all that data, 100% of the data that I just sent, was set to the default destination, which is in fact dev null. So that data went into the bit bucket. But what if we wanted to send that data somewhere else? To accomplish this, we just add a route. We'll click on Add a Route, and we'll call this route Data Loop. We'll tell it to use the pass-through pipeline because we're not going to modify the data. But we would like to specify that the data that comes from the destination in Cribl HTTP. It's worth noting, by the way, that this source is an unmetered source, which means you do not pay in Stream for any data originating from this source. It can only be sent by other internal applications like Search. Then where do we want to send it? Well, as a reminder, we have a data lake destination that we already created. So we'll tell it to send data to that data lake. And then we'll take that route, drag it to the top, and note that that is a final route. So anything that comes from in Cribl HTTP is routed to that data lake destination. That should be it. We'll save it. Once it's saved, we'll hit Commit and Deploy. We can add a comment, data lake loop, like that. We'll commit and deploy. Okay, so we'll just give that a minute for all the commits to sync and all the workers to be updated with that configuration. Once we've done that, we should be able to observe in the monitoring menu the route that we chose. The data loop route is not only enabled, but it will pass data from our source in Cribl HTTP to our destination, which is the default data lake. You see that 1,000 events went to dev null before, and hopefully when we run the search again, something different will happen. Let's go back into Search to run the search, send the results to Stream. So I clicked on the Search tab, hit Search again. Now this is going to take that same 1,000 events from Search and should push them into Stream. Let's look at a 5-minute view, and we should see that the 1,000 events went from the in Cribl HTTP source and were then routed to the destination data lake as we expected. But where does that leave us? Where is that? Where do those events go? Well, as a reminder, events in the Amazon S3 data lake are in fact searchable. We did that in the previous step. We should be able to go into search and easily find the events that we just sent from search. This is interesting and useful because now you have the ability to create a subset of your data, save it back to S3. Let's create a new tab here in search. As we did before, we can search the data lake dataset simply by clicking on its name here in the dataset list. Let's set it to search across all time. And there's our 1,000 results as expected. Great. One other interesting feature, if you're sending more and more data to the data lake, you might want to keep track of each individual result set. So for example, we just sent those 1,000 events here from Cribl internal logs, and we might maybe want to tag that result set to help me use it later. I can very easily add a modifier. For example, I'll add the extend operator, and then I can give it a name. We'll call it, let's say, tag equals, and then I'll put, let's say in quotes, I'll use my name, Cavuto test 1. And now we execute this search to see what it does, and we should see every event now has a field in it called tag with a value of Cavuto test 1. And we can confirm that if we hover over the fields view on the left, you should see that again. The tag is appearing, and then if we click on the fields tab, we should see a tag field with 100% of the events showing that Cavuto test 1 tag. Now if we take the results and pipe them to the send operator as we did before, we should see that the results now get sent to stream and the results get routed back into the S3 bucket, and then we're able to search it again over here. And we should see that there are now potentially 2,000 results in the data lake. Half of them will now have a field that shows tag that we had just added to it, Cavuto test run. So very easily I could simply search for Cavuto test 1 like that as a simple string. Now I have my data set instantiated specifically in search without any additional changes. In this way I can take a large complex data set, execute a search on it, push it into the data lake, and give it a name essentially. And that name becomes a search object that I can search on. Finally, there's one additional nuance we can perform to make this even more efficient if we know we'll be searching by this tag all the time. We can ask the data lake destination to partition the S3 bucket by that tag. So if we go back into stream, notice there's a partition by fields field, and we can tell it to partition by the field called tag that we just created. We'll hit space, so it notes it. We'll hit save. Once it saves, we'll go through the commit and deploy process. We can add our comment, adding a tag partition to data lake. We'll give that a moment to execute, and once that has committed, we should be able to run another search back in search. Let's say we call this tag equals Cavuto test 3. Take a look at what this looks like here. And now let's say instead of this 1,000 events limit, we truly want all of the logs in the past hour. We might not want to see those, so we'll just go right to send and send that full result over to stream. And maybe that set is large enough that we don't want to see it on the screen, but we've added that tag specifically Cavuto test 3, and we can see a tag field actually does appear here in the results set. Now we can take that data and again just hit send, and that should be sent over to stream, and it should loop back through the data lake. Now finally, if we go to search, we should be able to see not only that we're able to search by that specific tag, we should be able to search and see all of the several executions of that search, which was around 6,000 results per execution. After 3 executions, we get about 17,000 events. But the point is that's more efficient because we have the ability to partition by the tag in the bucket itself. In fact, if I bring the S3 bucket back into the browser, we should see that tag as a folder. We look inside the data lake bucket, drill down into today, you should see that there's a tag equals Cavuto test 3 folder, which is inside of that bucket. That point is that we can now specifically ignore any other files when searching that source other than just the files in this particular subfolder. So now if we're creating additional data sets, we have the ability to now partition those data sets. In the next and final video, we'll use this data loop configuration to explore a large data set, create a subset of it, send it to the lake using a tag, and then compare the difference in access and search summarization times for the original dataset versus the data lake dataset. Thanks, and happy searching!